Hi, my name is Hee-Seung Moon from Yonsei University. I'll present my paper titled Optimization-Based or User Prediction-Based Haptic Guidance. Can you do even better? Haptic guidance can be defined as a guiding force which is delivered to a user and assists the user to improve the task performance. For example, in this paper, we built virtual hierarchy environment which can be controlled by a haptic device, so the users can decide their input, receiving the haptic guidance which assists them to play better. In this study, we focused on the point that there are two approaches to implement haptic guidance. First, there is optimal action-based guidance, which conveys the most optimal action in the current task state. Second, there is user prediction-based guidance, which predicts the user's next movement and assists the predicted movement. So, this study starts with the two following questions. What is the difference between optimal action-based and user prediction-based haptic guidance? And is it possible to design a better haptic guidance by combining them? In the process of answering these questions, this study includes the following contributions. We presented deep learning-based approaches to implement optimization-based and user prediction-based guidance. Next, we proposed a method to combine the two types of haptic guidance. Finally, we experimentally compared the three guidance types through a user test. Now, I'd like to outline the method we present. For the optimization-based guidance, we trained an action model with a deep reinforcement learning method. And to teach an optimization to the agent without human intervention, we used a self-play-based learning framework. Moving on to user prediction-based guidance, a supervised learning method was applied to train the user prediction model. During this process, one of the challenging points was to model the behavior of different users. For example, if we use one fixed model, different users' behavior cannot be efficiently expressed. Also, training separate model for every user is even harder because it's time-consuming and data inefficient. To solve this problem, we trained the prediction model by applying a meta-learning approach. We used the model-agnostic meta-learning algorithm, which is one of the promising methods that trains one model to be easily adaptable to perform different tasks. Therefore, our user prediction model can be adapted to different users by updating the model parameters with only a small amount of data samples. Finally, for the combined guidance, we start with the point that the disagreement between the guiding force and the user intention is the main reason of the decrease of guiding performance. We present a simple but intuitive combining method that uses similarity of the two haptic guidance, so provides guiding force only when the target action is optimal and also meets the user's intention. We conducted a user test to validate and compare the three types of haptic guidance in terms of objective and subjective metrics. We now summarize the research into answers to following three of our research questions. First, do optimization-based, user prediction-based, and combined haptic guidance improve user task performance when compared to the no haptic guidance? Yes, all three types of haptic guidance lead to a significantly higher win rate. Second, what difference do optimization-based and user prediction-based guidance have in users' objective and subjective evaluations? Objectively, several different playing styles were observed depending on the guidance type, but there was no win rate difference between them. Subjectively, participants significantly preferred user prediction-based guidance in terms of naturalness, controllability, and comfort. As a final question, can combined guidance provide better effects in users' objective and subjective evaluations? Our combined haptic guidance significantly lowered the actual disagreement even without reducing other objective and subjective metrics. This implies that our combining method was effective in minimizing unnecessary interference to users. So, this is the end of my presentation, and we expect that our findings can contribute to better design other haptic guidance-based interactions. Thank you for the listening.